and once we feel logically we have achieved something, then what we'll do, we'll save that as a checkpoint, right? Right. So pretty much similar to how we have checkpoints in the games that we are playing, right? It is not that we'll complete the final mission, right? So in a game we'll have many missions, right? One, two, three. So thereby we'll have save points and checkpoints, something like that. Git has something called commit-based mechanism to save our changes, right? So we save our changes as multiple snapshots. So a commit represents such snapshot that we are making in a particular point in time. So meaning if you are creating a snapshot, whatever changes that we are doing, it will be added to the repository, right? And then we can get back to these commits, and then we can work on later. And then if you want to make changes, or if you want to do any deployment based on a specific commit, we can do that, right? Right. So apart from repository and commit, the next important term that we used very frequently is something called branch. So what is a branch? A branch is a parallel version of a repository, right? So it is an parallel version. So if you don't want to make changes in the current repository, so what we can do, we can create a parallel repository and then we can make changes. So it won't affect the primary version, or rather the primary branch, right? So for instance, there is a main branch, main repository, where and that is being deployed. Now I want to add one more feature. If I'm adding the feature, and for me to add that feature, if I'm making changes in that main repository itself, chances are there that it might break the current deployment. So what we usually do is that we'll create a parallel repository, and then we'll make changes. Whatever new changes that I intend to do, or a developer intend to do, he will do that in the parallel branch without affecting the primary branch that is linked to the production or the current deployment. So in that way, so if you want to introduce new features or new changes or new bug fixes, we can create multiple parallel versions of the repositories. So we call them as multiple branch. And in a given point of time, one can switch between any of these branches, right? One can switch between any of these branches, track changes, merge it with the main branch, and then go for the new deployments, right? Right. So as we speak about branch, and then we have something called master branch. So master branch is the primary branch of the Git repository. So this typically represents the stable version. This typically represents the stable versions. And like I mentioned, for us to add new feature, we don't typically do changes directly in this main branch itself. So we create a new branch, and then we name it accordingly, right? And how are we going to create branch, and how are we going to name it? So these are all comes under the branching strategy, right? So we exactly need to plan and how we need to create branches, how I need to name it, when I need to merge it with the main branch, something like that, right? And as you can figure out, as you can guess here, there are multiple developers, and then individual developers will be having their own branches, right? If individual developers are going to have their own branches, then it will create chaos. If it is not properly planned, it will chaos. Assume just think about 10 or 11, I mean more 10 to 12 developers started to commit to the main branches over the period of time, right? So there are chances that there will be more conflicts, right? So how are we going to effectively manage the conflicts? So conflicts will be there, we cannot avoid it, but how can we effectively manage these conflicts? So that is where we need to have a proper branching strategy, right? So master branch is the primary branch which represents the stable version of the code base, right? And then remote. So remote is a copy of the repository hosted in um, a web platform, right? So Git we can have our local repository, and then we can also have our repository in the web platform as well, right? So you might have heard about GitLab or GitHub over the time, right? So these are the web platforms, right? Right. So you might have heard about GitHub or GitLab, something like that. So these are all the web-based Git platforms. So these platforms allow us to manage our Git repositories in the online. So what we call as a remote. So we can have our Git projects in our local. Typically, the changes that we do that we'll do in the local, right? So now how I can make it available to everyone? So typically I need to move it to a common location, and that is where this Git platforms, web-based Git platforms will be helpful. So where we can manage our Git projects in the online itself, and then we can make everyone else to collaborate easily. Right. So if the project is in my local, then it will be a key challenge for me to collaborate others as well. Right. So what I'm doing here, so with these web-based Git platforms, I can manage my Git repositories in the online, and it will be easy for me to collaborate with others. Right. So remote is a copy of a repository hosted in a web platform. So example, GitHub is there, Bitbucket is there, and then GitLab is there, and then we have few more repositories, right? So widely used is GitHub, Bitbucket, and then GitLab, right? Clone. So cloning is the process of creating a local copy of the remote repository. Now that we have a remote repository, how do I make that project available in my local? So as a developer, I want a project, maybe an open source project is there, that is there in the made available publicly in the GitHub. Now I want to make changes in that open source project. So how can I do that? So what I'll do, I need to clone that project in my local. So cloning is a process of creating a local copy of a remote repository, right? So if I'm making a local copy of that remote repository, now I can make change in my make changes to the repository in my local itself, right? And over the period of time, if I achieve a logical implementation, then I can get to commit that back to the remote repository, right? Fetching retrieves all the changes in the remote repository. From the time I have cloned, there will be other developers who will be making changes in the remote repository, right? So now how will I fetch the new changes that are happened after my initial cloning, right? So after cloning, so I've cloned in one point of time, and after that point of time, there will be multiple other developers who will be making changes, who will still be making changes in the remote repository. So how will I make those new changes available in the repository that I have initially cloned? So that is where we have something called fetch, right? And then pull, right? Push, pull, and clone. So clone is about we saw what is a remote repository. Clone is about cloning a remote repository to our local. A pull is about pulling a remote branch to our local repository, and then push is about whatever changes that we made. Now we can push it to the remote repository, right? And then we have something called merge. Merge is about I mentioned we have multiple branches. So how we can right? We have multiple branches. At the end of the day, what will go for the deployment is that stable branch, right? That main branch. So how will you merge the other branches with the main branch, right? So that is what merge is about. So merge is about merging branches, right? So how are we going to integrate changes from one branch into another, right? So there are a few more things. There is something called staging, and then we have git ignore. So these are the primary terms about git, right? And then there are a few more terms. I think probably we'll explore it by the time when we will start working with git, right? So now how can we get this started? So for us to work with Git, we need to install Git, and then we need to do some initial configurations. And then once Git is available in our machine, what we need to do, we need to convert our project into a Git repository, and then we need to see how effectively we can use Git to track the changes, right? Right. So what we'll do, we'll start with the basic Git commands, like we discussed here, and then we'll also have a glimpse at how these web-based Git platforms that we mentioned, like GitHub, GitLab, right? So we can take one example, rather either we will take GitHub or GitLab for example, and then we'll see how this adds to the initial features of Git, right? Right. So I already installed Git in my machine. uh, to install Git. So you need to go to the official website of Git, which is Git SEM, where you can download Git for our platforms, and then we can get to install it. Right? For instance, I'm using Windows in my machine. I've already downloaded the Windows version, and then I've installed. Right? So you can click this. Setup file will be downloaded, and you execute this setup file just like any other application. This will Git will get installed in your machine. Right? So here you have a version for Windows, and you can also find the version for Linux in case if you are using Linux, or you can even find one for Mac as well, right? So Windows, Linux, and Mac. Depending upon your version, you can get to download, right? And then you can install it, just like installing any other application in our machine. So once done, the way we verify is by opening a terminal, and then you just need to say Git version, right? So if Git is installed in our machine, it will say the version, or otherwise it will display Git is a not recognized command, right? Right. So now that Git is installed in my machine, now we'll see how we can convert a project into a Git repository and how exactly we can track the changes by using Git. Right. Can I proceed? You have any questions before I continue to the next steps? Is Git SEM? No, see, Git Bash is just a client. When we say Git Bash is just a client that we use to interact with the Git, right? So typically Git SEM, they are same. Git SEM is the name of the site. Git is the name of the software. So typically it is called Git, and then Git Bash is just a terminal. So right now I'm using this window terminal. This is command prompt, and there is one more terminal called PowerShell. Right. So there is one more terminal called PowerShell. Right. And just like these two terminals, Git by default comes with a terminal that is called Git Bash. Is that fine, Amin? So either you can use this command prompt, or you can use a PowerShell, or in certain cases, if you don't have a native terminal, right? If you don't have a native terminal, then by the time when you install Git itself comes with a terminal called Git Bash. Right. So now this is Git Bash, a native terminal. I mean a terminal that comes with Git Bash, right? A Linux based terminal, right? If you don't want to use command prompt, then you can use the Git Bash. And then again, all these terminals, including Git Bash, command prompt, PowerShell, these are only for the initial learnings. And going forward, right now we are having many more GUI based terminal clients, right? So whatever that we are doing via commands, we can typically do by using the GUIs, right? User interface, typical user interface, right? It is not that terminal is the only option, only options that we have to work with Git. So this is a uh, uh, initial thing that we do, but once we have understood things, then it is not that we need to use only terminals. So all the editors like VS Code, IntelliJ, whatever editors that we are using, they have native GUI clients in order to work with Git in a better manner, easier manner. Right. So I have Git installed in my machine. Um, Now what I need to do, let me take a sample project, and then we'll see how we can work with Git in that project, right? And for this purpose, in my workspace, right? So in my workspace, I'm going to create a project, right? I'm going to create a project. Let's say, right? So I'm creating a project folder in my workspace. I'm naming it as NTW Git session demo, right? Session demo, and then I open this project in a editor, right? So typically I'll be working with the editor, right? So I'm going to open this in an editor called VS Code. Right. Right. So I prefer you can yeah, you can use a and there are not just GitHub desktop or fork. You have multiple other options. Like for instance, the code itself. I mean the editor itself that I'm using. They also come by default with the Git UI clients, right? So it is not that you need to have like I mentioned, it is not that you have to use only the terminal clients. There are multiple options. Yeah, GitHub desktop is also a better options. So these are the things that you can explore going forward. Fine, Afik. Right. So there is no preferred GUI. Initially, you can go with the terminal itself for learning purpose as a beginner, so that you can get to know how basically Git is working, and then you'll be able to understand things around. And once that, like I mentioned, I know GitHub Desktop is a better option, or even without GitHub Desktop, most of the editors that we are using, like the VS Code that I'm using, they comes with the default the GUI clients, right? That we can use. Right. So I open the project in VS Code. VS Code comes with an internal terminal. Right. So now what I'll do, uh, I want to know the current status of the project. Right. So I want to know the current status of the project. So the very first command that I issue for this project is now I'm inside this project. So I created the project and and right now I am in the root directory of the project. So the very first command that I issue is I'll say git status. So this command lets us know and what is the current status, what is the current commit, when the last commit is made, something like that. What is the current branch? So it gives the current information about the project. So right now it says not a Git repository. So meaning this project is not at a Git repository. So meaning I need to convert this into a Git repository. This is just a normal project. So I want to convert this into a Git repository. And speaking about these Git commands, right? So Git, I mentioned I've started with Git status. Going forward, we are going to issue few more Git commands. But how can I refer these Git commands? So typically, you can download Git cheat sheets where you can find these Git commands online to help us, remember these Git commands at least in the beginner stage. Or else, you can find this Git SCM itself, right? So Git SCM itself is a good resource where you can find the basic Git operations, right? So if you go to the Git SCM documentation, you'll find all these basic commands, setup and config, init, clone. So these are the basic Git commands that we are going to do, right? And apart from this, this is a bit more comprehensive, uh, right? This is a bit more comprehensive. Might be difficult for anyone to understand. And there is uh, another um, reference that you can go with is Git Atlassian Gits rather. Right, so you can find Atlassian Git. In Atlassian, you'll find informations about Git. So where you can, this is also a reference where you can find all these basic commands. For us to learn the Git, right? So Git init, Git clone, Git config, and you can also download the cheat sheets, Git cheat sheets. Right. So these are some of the ways where you can remember these commands. Right. So right now I'm in my project and it says not a Git repository. So now how do I enable Git in my project? So whatever changes that I do, it will not be tracked. It has to be manually tracked. Right. So I want Git to track these changes. So I need to convert this into a Git repository. So the command git init is the one that converts a normal project into a Git repository. Right. So now we'll get something like initialized empty Git repository. So meaning now that this is a Git repository. Right. Right. So now this is a empty Git repository. Right. So now this project is converted into a Git repository. Now whatever changes that I do, it will be tracked by Git. So I'm doing Git status again. After git init, I'm doing git status again. Now I'm getting a different information. So I'm saying I'm getting on branch master. So by default, it is creating a branch called master. Like I mentioned, master is the primary branch. Master or main is the primary branch that will be created, and that is considered to be the stable branch. All right, and it says no commit set. No commit set. There is no previous commits, and then there is no changes for me to commit. So this is a prime. This is freshly a new project and then a new repository, right? And this command typically can be issued multiple times, and in and due to the fact this is dangerous command, right? So if this git init is issued in a typically a old project, it will reinitialize all the histories, right? If I say, you can see here, I'm saying git init again, it says reinitialized. So meaning the all the earlier commit history that will be rewritten. It will be reinitialized. We might get to lose all the previous change of histories. So this typically issued only once in a project, right? So typically in a start of the project, right? And as you can see, once I issued git init, I am getting a new folder called .git created, and you can see the footprint. It is only in KBs. So this is where the change informations will be stored. This is typically what we call as a commit history, right? So .git folder is where we have our commit history. Meaning, if I delete this folder, our history commit history will be gone. So this is what makes the particular project as a Git repository. So I'm deleted that .git, and I'll say git init again. Sorry, I deleted the project just to understand how basically this works. I'll say git status again. So I'm getting not a Git repository, right? So earlier it was a Git repository, but since I've deleted that .git, which is primarily responsible for storing all the Git related informations, I mean the change histories. Now that folder is got corrupted or deleted. Now it's saying not a Git repository, right? So this .git is the directory is the one that makes, or it's a key folder that will be that has to be preserved in all the Git repositories, right? So I'll say git init, initialized empty git repository. I'll say git status. It says no commit set, right? And I have this dot git. All right. So now what I'll do, I'll start. Now the moment you do start doing changes in your project, everything will be tracked by Git. For instance, I'm going to create a new file, right? So I'm naming it as first file dot txt, right? I'm saying first file dot txt. Now that I have made one change, and then if you can see here, I'm getting a different informations. The moment I say git status after creating a file, it says no commit set, right? And then untracked files, first file.txt. So there is a change that is to be tracked. So the changes are made. So the git is now able to see the changes, but these changes are not yet tracked. Meaning we need to tell Git that you need to track these files for changes. So that would be the next step. So we need to tell Git. So Git typically will see all the changes, but by default it won't track the changes. right? So we need to tell Git that you need to track these changes, right? So how do I make Git to track these changes? So which is what we call staging. Staging is telling Git that you need to track these changes for commits, right? So I'll say git add first file dot txt, right? Git add first file dot txt. So meaning I am staging the, I'm telling that whatever changes that are made in the, that are done so far in this file, that can be committed, right? Right. So it says on branch master, no commit set, changes to be committed. Changes to be committed. It says first file dot txt. So the changes that I did, that can be committed, right? And that this file is now being tracked. This file is now being tracked. So now if you create another file, I'll say second.txt. I'll say second.txt. Right. So we can see I'm getting a few more informations on branch master, no commit set. I didn't do any commit. Changes to be committed. So there is a change that I made, made and tracked, right? I've created a file and then I said git add. So these changes that I made so far in this first file, that can be committed. And then there is another change, but it is not tracked. It is not tracked by Git, right? Because I've just created it, but didn't tell Git that it needs to be tracked. So what I need to do, just like I told the Git that you need to track this file, I need to tell that you also need to track the changes that are happening in the file second.txt, right? So how do I track all the files? How do I track all the files? Instead of mentioning these files individually, I'll simply stage all the files. I'll say git add followed by a period symbol, which where I can tell Git that you need to track changes in all these files, all the files and folders, right? All right, I'll say now I'm getting first file, second file. All right, so now I'll start make the changes in first file. Welcome to Karanto. Right, first commit. So I'm making some changes, and in the second file as well. This is a change made in the first commit in the branch master. So I'm saying this is I'm making some change, right? I'm making a change. So I'm saying this is a change made for the first commit in the branch master, right? Right. I'm saying git status, right? I'm saying git status changes to be committed. So once when I created two files, I've staged them, I've added them, and after making that changes, I and after I know staging those two files, I made couple of changes. I made couple of changes, and then you see here changes not staged for commit, meaning these two files are commit, these two files are staged, but the changes made in that files, they are not staged yet. So I made couple of changes, right? You can see how Git is tracking, how Git is able to see all the changes, but you need to tell Git how exactly we need to track these changes, right? Right. So now I am ready to do my commit. I need to do my commit. I've created two files and I made some changes. I need to make a commit. So what I need to do, first I need to stage it. So Git typically Git follows a three-level workflow, right? Three-level workflow, meaning it has three trees, right? It has three trees. One is the working tree, right? One is the working tree. The other one is the staging. The third one is the commit, right? Which we typically call as a repository. So whatever changes that I'm doing in the working tree. Working tree. So this is not tracked, right? So when I tell git add, these changes will be tracked. So it is called stage tree, right? And then the moment you issue commit, whatever that are there in the stage, it moves to the repository, right? It goes to the commit. So work tree, stage tree, and then commit, right? Right. So now this is in stage. This is staged. Nothing in commit. No changes are there in the commit. Right. No changes that are there in the commit. A couple of changes are there in the stage, and a couple of changes that are there in the working tree. Right. Working tree. Right. So how do I do my commit? So typically it is simple. So I need to stage all the changes and then I need to commit. So how do I stage the changes? So I make changes, stage the changes. This is how I stage the changes. Either you can choose them individually depending upon our use case, or rather you can stage all the changes. You need to make some change. I need to stage that change. Right. I need to stage that change. So this is called staging, and then I need to commit. I'll say git commit. I need to commit all the changes that are in the stage, and then I want to give a message, right? So how do I get to recognize this commit? So I need to name the commits with the meaningful names. So that is where I'm saying m. So I want to create a snapshot here with a meaningful message, right? I say my created the files. Right. So I'm giving a meaningful name to identify the changes. Right. So now with this commit message, I need to name the commit relevant to the change that I've did. So the primary change that I did in this commit is I've created the initial set of files. So I'm saying git commit dash am where I'm telling all changes in the stage needs to be committed with a message. Right. I'm giving the message in the double quotes. Right. So now what it is showing, it's telling, please tell me who you are. Right. Now we have installed the gate. We have installed Git, but we missed a typical step, which is Git configurations, right? So Git wants to know who is making these changes, who is making the commit. So typically, no one needs to see a commit from an unauthorized an author without name in the project, right? So we are going to the we are getting access to our project, our repository, and then we are seeing a commit, and then we are seeing a commit without an author. So that is a uh, you know uh, a serious thing that one can get into, right? We don't want to see a commit from an unknown author. So how git ensures that it is not happening is by using this git configurations, git config. So for me to commit, now I need to tell git who I am, right? So I need to tell, so it gives this configuration thing. So I need to do these two initial set of configurations. Only then I can do the git commit. You can see unable to auto detect email address, right? I say Deepan at current.com. Right. So now I have provided this configuration. So git config is how you tell who is making these changes, right, to Git. So Git certainly wants to know who is making the changes, or otherwise chances are there the commits will be issued by the unnamed authors. So we don't want that to happen in the typical repository, and then hence this configuration has been made a mandatory thing before any commits happened. Right. So now I'll make the commit. Now that I've configured my username and then my email. Now I do my commit again, right? So now I'm getting a different information. It says created the initial set of files, two files changed, three insertions, right? Now I'll say git status, right? So now it's saying on branch master, nothing to commit, working tree clean. Meaning, and right now, if you compare this with our previous informations, the previous time when we issued git status, it showed no commits yet. Now that information that message is not there now, right? Because now that we have a commit, right? So now how do I summarize all these commits, or rather, how do I see all these commits? I need to say git log, right? So if you say git log, it will show all the commits that are made in the past, right? And you also find the author and the date upon which the commits are made, right? So I have one commit. The name of the commit is created the initial set of files, um, and then the author is Deepan, and the time is you can also see the time as well, right? Right. So now after this commit, I want to do further changes, right? How do I do that? So I go to my second file. I'll do a change. Right. I'll say this is an update for the after the first commit. Right. So this is an update after the first commit. So I'll say git status. Right now I'll get a different message. Right. So you can see here as we make changes, Git continues to track these changes. Git continues to track these changes. So I keep on make changes. I keep on make changes, and then what I'll do once I reach a logical completion, once I get to implement a particular feature or thing, I'll get to commit, right? So how do I commit? I stage, I made a change, I staged it. Now and say the changes are staged, and then I commit. I'll say git commit -am, and then I'll say updated the second file. Right. So now there are again the branch is clean. The working tree is clean. There are no changes in the working tree that has to be committed. So whatever changes that are being made so far in the working tree, they are committed. So like I mentioned, there is three tree: working tree, stage tree, and then commit. So all the changes that are made in the working tree is staged and then committed. So hence working tree is clean. The moment you start doing changes, you see the things will get reflects in the git status, right? And now if I say git log, I can see two commits, right? I see two commits. One is that the initial set of files, the other one is the second file, right? Mm. Can I proceed? Right. So now let me see how do we create parallel branches. Right. So now I want to make some change, but I don't want to make the change in the main branch itself. Right. I don't want to make this change in the main branch itself because I don't want to affect my new changes. I don't want my affect my master branch with my new changes. For that purpose, what I'll do, I can create a new branch. So how do I create a new branch? I'll say git. So either you can say branch. Right. So there are a few commands that we can use to create a branches, right? So the effective one that I use is that git checkout. So I say git checkout, I'll say dash b, and then I'll give my branch name. So I'll say feature branch. I'll say uh, feature one, something like that. Right. So how do we get to name the branch? It's depend upon what feature we are implementing or what exactly is the objective of creating the branch, right? So that will typically explain the reason for that branch, right? So typically we used to say dev branch, right? So meaning this contains the development code, something like that, right? So master is the primary branch. Right now here I'll say feature branch, feature one, something like that. So this will create a branch called feature one, and then we will be uh, moved to that branch. So right now we are in the master branch. So this command, what it will do, it will create a new branch called feature one, and then it will also default takes to the new branch, right? So I'll say git checkout feature one. So it says feature one did not match any files known to git, meaning I'm trying to move to feature one from master. So I'm trying to move from, right now I'm in the master branch. By saying git checkout feature one, I'm trying to move to feature one from master, which I'm not able to because there is no such thing as feature one. So typically what I want to do, I want to create a new branch called feature one, and then I need to move into that feature one. So for that purpose, I'll say git checkout, and then I'll say dash b. Dash b will create a new branch. In case if this branch is not there, it will create a new branch, and then it will move into that branch. So I'll say git checkout dash b feature one, and then if you notice, we have a message called switch to a new branch feature one. Right now, from this moment, whatever changes that we are doing, that will not affect the master branch, which is in our case is the primary branch. Right. So in the feature one, I'll create a file call, or rather I'll say git status. Right. I'll say git status. Now it says on branch feature one, nothing to commit. Right. Nothing to commit. So in feature one, there is no changes that are to be committed. It is typically clean. Right. So here I add a feature. So I'll say feature dot text, feature or other feature one dot text. Right. So I created a file here, and then I'm making a change in the file. Right. So I created this file. Right. So this file is not a tracked. Right. This file is not a tracked. So what I'll do, I'll make changes and then I'll stage it and then commit at once. Right. I've added feature one dot txt. And then I make some change here. This is a new feature. Right. This is a new feature. Its status. Right. So in feature one, there we have one change that is untracked. Right. I made this change. I want to commit now. So what I'll do, I'll stage this change. How do I stage? By saying git add. Right. I say git add a period to stage all the changes in that working tree. Right. I'm not specifically picking a particular file. Rather, I'm trying to stage all the changes. Now that I stage, and then I need to commit. I'll say git commit. I'll say feature one completed, something like that. Right. I'll say feature one completed, and then I'll say git status. Right. So no, everything is committed. I'll say git log. Right. So I'll say git log. There are three commits. Right. There are three commits in feature one. Right. So now this thing, the feature one thing that I did, it is done in the feature one branch. Now let me check out to master again. I'll say git checkout master. The moment I move to master, we can see that I'm not able to see that feature branch here, right? The editor is also showing that this file is not existing, right? Now I'm in master branch, no commit set, git log. Here it is showing only two commits, right? It is only doing two commits. So reason, right? So the commit that we did, it is in the another branch, right? So how do I list all the branches? I'll say git branch, right? So I say git branch, it will list out all the local branches, and then it will also point the current branch. It will also point out the current branch we are in. Right. So I'll say git checkout feature one again. I'll say git branch. Now it says feature one. Now it is highlighting feature one. Now I'm in there are two branches. Right now I'm in feature one. I'll say git log. There are three commits. All right. So now how do I merge this? I need to merge this, right? So if this has to go to the deployment, it has to move to the primary branch, right? So what I do, I go to the target branch. I go to the target branch and then I'll say git merge feature one. Right, git merge feature one. So I did changes in the feature one branch without affecting the master branch. Once things are stable in the feature one branch, and then what I'm doing, I'm merging to the master branch. And now, and how do I am merging it? I move to the target branch. So in this case, the target branch is the master. So target branch refers to the branch to which we want to integrate the changes, right? So I want to integrate changes to master from feature one. So in this case, the target branch is the master. So I move to I check out to the master branch, and then I say git merge with the source branch. So in this case, feature one is the source branch that contains changes that are to be integrated. So I say git merge feature one. Now the things are getting whatever that are commits that are there in feature one that will get integrated with. So typically it will get integrated with the master branch, right? So it will place the commits one after one above the other, right? So there are two commits in the master, three commits in the feature one. In these three commits, two commits are same. So it will typically place those merge those two commits, and after merging those two commits, it will add one commit uh, sequentially after the first two commits. Typically merge will merge the commits, right? So I'll see three commits here. So I'll say git status. So now I should be able to see when I say git log, I should be able to see three commits in the master itself, right? Right. So now how right now there are no changes that conflicts with the other change. Now what if the changes are conflicting? For instance, in the master branch, right? So in the master branch, I'm doing a change and then I'm committing it. I say change in the master branch. So in the second file, third line, I'm doing a change in the master branch. Right. So I'll say git status and then I'm committing it. How do I commit? I'll say git add and then I'll say git commit. All right. So now the change that I did, this is only available in the master. Right. This is only available in the master. So now what I do after making this change and committing this change, I'll check out to the feature one branch. I'll check out to feature one branch where the change that I did in the master is not present. Alright, so the third line I'm not able to see here because that change is available only in the master branch. Right, so now here in the feature one, so I'm going to make a change in the same third line, where it has a different version in the master branch, and now things are getting into conflict. So earlier in the earlier merge, we don't have any things that are conflicting with master. So the changes that we did in the first one, that entirely new uh, from the changes that we did in the master. So none of the changes that we did uh, that I did earlier in the feature one is not conflicting with the master branch. Now that the change that I'm going to do in the second file, where I'm going to add a third line in the feature one, this will conflict rather with the change that I did in the master. Right. So now I'll say this is the third line added in the feature one branch. Right, feature one branch. So I'll say git status, I'll commit it. I'll say git add. This time I'm committing in feature one, right? Just like I did I'm creating a conflicting commits. I'm creating conflicting commits, and this is a typical use case where multiple developers will work and multiple developers will make changes in the same files in their own repositories. And the moment they try to merge the same files where they made changes, that will conflicts, right? And this is a primary thing that needs to be addressed. And if there is no proper plan, managing the conflicts will be a hell of a thing. And that is where we need to have a proper branching strategy. The way we are committing, the frequency at which we are committing, the way we are creating branches, how the branches are allocated, how they are deleted, all those steps, right? How frequently commits are to be made, right? And how frequently the commits have to be merged, right? So this typically forms a branching strategy in order to handle this scenario effectively, right? Of course the conflicts will be there. The conflicts have to be, we should be in a situation where we need to manage these conflicts more easily and effectively, right? So right, I'll say git status. Yeah, now I need to commit. I've staged the change, now I need to commit. Right, updated second file. Right, so now I check out to master. Now I check out to master. So here I have a different version of the change. So here it says change in the master, whereas if I check out to feature one, here it has a different version. The same third line, it has a different version. So we have a conflicting thing here, right? Right. Now I'm in the target branch. I want to merge the feature one branch. I'll say git merge feature one. I'm in the target branch, which is the master, and then I want to integrate changes from feature one. Right. So now we see here. I'm. This is not. The merge failed. I'm getting merge failed. So auto merge failed because there is a conflict. Merge conflict in second .txt. It says automatic merge fail, fix conflicts, and then commit the result. So now I need to fix the conflicts, right? I need to fix the conflicts. As you can see here, the conflicts has two parts. One is the head, and the other one is this current change, and then the incoming change, where we manually need to decide which change that we are preferring, either this one or this one, right? So depending upon that, you need to remove things. So what I do, I'll take this change. I'll prefer this change, the one that is in the feature one, and I'm going to remove it. All right. All right. So git status on branch master, you have unmerged path. So unmerged both, right? So in second.txt, so it has pulled the change from the branch, but it's not able to commit because of the conflict. So where we manually need to intervene, resolve this conflict, and then we need to merge. Right. Right. So now I make change. Right. So I take the change. So there were two options. One is that we either go with the version, either we go with the one that in the master, or rather we can go with the one that is in the from the branch. So I'll go with the one that comes from the branch, and then now I'll say git status. Right. Right. So all conflicts fixed. Now it says all conflicts fixed, but you are still merging. Right. Git. I fixed the conflicts, staged the changes. Now I'm committing. Right. Now there are no. Now there are. Now the working tree is clean. Right. And everything in the master branch is committed. Right. So we saw how we can initialize, right? How we can, meaning how we can create a Git repository, what is staging, and then what is committing, right? We saw how Git typically manage the changes, and then all these things we are doing in the local repository. Now, how do I move this to a remote repository, right? And that is the critical. So as I said, we need to have a common code base, right? Common location where everyone we need to have a repository location where is it easy for us to collaborate others as well, and how effectively we can do that. As long as a project remains in my local, it will be difficult to do that collaboration, right? And this is where we can use the online web-based Git platforms such as GitHub or GitLab, right? So now what I'm going to do, I'm going to push this repository to a remote repository, right? To a remote repository. So how do I do that? So I'll go to my browser. I'll go to my browser. I log. So for this purpose, I'll take my GitLab account for example. I'll go to my GitLab, gitlab.com. Right. So either you can go with GitHub or you can go with GitLab, like I mentioned, or you can go with Bitbucket, whatever thing, or you can have accounts in all these things, and then you can try out things. Right. I'll sign in my GitLab account. So if you don't have your account yet, you can create one account. You can use your Gmail itself, and you can simply say sign in using Google, it will get logged in. All right, and in this case, I'm already having my account. Right, I'm already having my account, and then so these are the projects that I'm having in my remote repository. Right, so these are some of my projects, yearly projects. Right. So how exactly you can collaborate here? So here you can create the repositories, you can manage your repositories online, right? You can manage your repository online, and then here also you can edit. So most of these Git platforms, they come up with the web id, come up with their own id. So for small changes, or even now there are now cloud based editors. Now that you are having cloud based editors, you can make changes entirely in the browser itself, right? So you don't even need a local editor, right? So for simple changes you can edit. So by default it comes with the editor, and right. and online workspaces where we can manage the project in the online itself, right? You can see what are the activities that are happening in the project. You can add members to this project. This is how you can control the access, right? So you can add members and then you can assign them roles. For instance, this project is having one member, and then I'm the owner of the project. If I want, I can add some other member, and then I can make them as owner, maintainer, or reporter, something like that. So different access controls. So you can check out what are these access controls. So individual Git platforms will be different in this access control, right? So for instance, GitLab is having roles like owner, maintainer. It has a role called reporter, right? It has a role called developer. So these are the default roles. If you want to have a few more roles, you can create it, right? And then you can give permissions, right? Right, and then you can also track the changes, right? So for instance, what are the branches, what are the commits, right? I'll go to the branches. Here I'll be able to see what is my branch. So right now it is having, this is not the project that we have created. This is one of my old project, right? So this is having only one uh, uh, branch, which is called master, and this is a primary branch, right? I can see default here, and this is protected, meaning this is a protected branch. Not everyone can make change in this branch. So typically, one with the higher permissions, like the owner or maintainer, will be able to edit in this project, right? So what are the commits in the branch? So there is only one commit, right? So if we want, I can add tags, right? So this is where I can add version, right? Something like that. So apart from that, we were speaking about automation, how we can set automations by using these pipelines. So I can create automation pipelines. I can create jobs and I can schedule the jobs. For instance, I can create a CI job, right? Meaning, right, I can write test cases and then I can schedule these test cases to be executed at one point of time. Or I can create a trigger, right? When I can create a trigger, and based on the trigger that CI pipeline will get executed. Trigger in the sense, whenever I make changes in a master branch, I can uh, execute that trigger, something like that. Right, and apart from that, you have something called issues. This is how you can get to review and raise the issues. Right, this is how you can get to review things in the projects. Right. So typically, you can raise the issue and you can assign someone else to review the code. This is one way of effectively, communicating with the others. Right. So you can see there is a comment section as well where you can write your comment for others. So typically in all the public repositories in GitHub or GitLab, you can go to the issue section, you can find all the things that are happened. And then you can also have a board view, a typical Kanban board where you can track the issues, right? Right. You can set milestones and you can also have a wiki page, right? And whatever things that we are doing here, this will be notified to the mail address as well, right? For instance, these are some of the mails that I have received from the GitLab, right? So what are the things that are happening? So one of the key steps in source code management is effective communication, right? So we need to have effective communication. So that includes whatever things or whatever activity that are happening in the project that has to be communicated, right? And this by default comes with all the Git platforms like GitHub and GitLab, right? Right. So now how do I move my this project, my the project one that I am having in my local to the remote. Right. So I create a new project. So I'll say create blank project, and you can see other options as well. Import project, create from template. So here I'm not going to create any project from template, nor I'm going to import from any other platform. For instance, you can see here you can import to see that affect that depend upon your use case. So for instance, I'm having account in both GitHub and GitLab. So it depends upon the features that they are providing. For instance, sometimes back in GitHub, there is a limitation in the number of private branches, private repositories that we can have. Now that we don't have that restrictions, now that we don't have our limitations. And similarly, GitLab is having a limitation in terms of running the pipelines. So it depend upon our requirement, right? So GitHub earlier had a restriction in the private repositories, which was not there in the GitLab. So we were using GitLab for a long time. Now there is not much difference in terms of managing the private and public branches. So we were using GitLab and GitHub. GitHub is having edge over that GitHub Actions. Earlier, GitHub doesn't have that feature. GitLab was having that automation feature called GitLab CI. We were using that GitLab CI for some times in the absence of GitHub Actions. Now that you have GitHub Actions where we can set up the pipelines, we've started to use GitHub. So it depends upon our requirement. So personally, I prefer both GitHub and GitLab, and for specific use cases. Fine, Afik? Yeah. Yeah. Right. So one way to explore is that now that you know what kind of features that you are finding in GitLab, you see whether similar features are there in the GitHub, right? So typically it will be in different names and you see what is the limitation. For instance, in GitLab CI here I can run multiple CI. With GitLab, I can run multiple CI, but the thing is that I can only run using a shared instance. I cannot have my own private instance. Whereas in GitHub, for running the CI, we can have at least one private instance, and then we have that limitations. So depend upon our need, right? So it is better to have account in both GitLab and GitHub. Both are open source solutions. We will have access to all the primary features that we require. Right. So now that I'm going to create a blank project. Right. I'm giving a project name. I'll say NTW 2025 demo. 2025 demo. And here I need to pick a namespace. So apart from projects, this can also have groups, right? So I can show the groups later, right? So we can also have groups where we can add our projects. It is not that we need to add only in the dashboard. So within our GitLab, so this is same for GitHub as well, right? So we can have groups. So it is asking me in which group I need to create this project. So I'm saying I want to simply add to my user account, not to a specific group, right? So I'll say my group. So now this is the project name. This is the account in which I want to create the project. And this is the so this is typically the project path. I'm not choosing any deployment target yet, and this is going to be my private project. If you want this to be publicly accessible, you can select public. Now if this is the case, provided that link, anyone can get access to the project, right? So in this case, since this is a session demo, I'll go with the public itself, right? And I don't want this to be initialized with the readme file, right? And then I'll create the project. So I give a project name. I selected my user account where I want this project to be created. No deployment targeted. Or if you are having a deployment platform that is ready, you can select accordingly, right? You can do this manually, or if you want help from GitLab or GitHub, you can also get to choose. So this is typically a template depending upon the platform to which we are going to deploy. If it's typically an application that we want to deploy, you can get to choose a template, right? So it will give you an initial configuration where you can edit that. Right now, I'm not going to deploy this to anywhere. I've left this blank and I'm selected public, right? And now I'll say create project. Right now I have created the project. This project is typically empty. I'll copy the URL of this project. I'll say HTTPS, right? I'll copy the URL of the project, or you can also typically copy this one. So this is our project path. So whatever project that we are creating in our GitLab, they'll get a unique URL. So this is typically the URL that we are seeing in the address bar. That will be the unique URL through which we can access this. This is a public project, right? This is a public project. So anyone should be able to make changes here. I'll copy this URL. Right. Now I'll go to my local project. Right. So I'm in branch master. I want to push the master branch to the here, right? To this repository, to this remote repository. Now this is a local repository. I want to push this repository to this remote. Specifically, I want to push the master branch. So this repository, this local repository is right now having multiple branches. So what I'm going to do, what I want to do rather, I want to push my master branch to this repository. So I'll copy the URL, project URL. I'll go to my local. So I'll say git remote. Right. So I'll say git remote space /v. It doesn't show me anything. So I'll say git remote add origin. So I'll say git remote add. So meaning I want to add a remote URL, right? Remote repository, right? So I'll say git remote add, and then I need to name that remote repository. For this local repository, uh, how I can make this local repository to refer to that remote repository. For that, I need to provide a name. So the name that I've given for that remote repository is origin. Then and then I'm providing what is going to be that remote repository. I'm providing the URL of that remote repository. So git remote adding a remote repository. I'm saying add a remote repository. How I'm going to refer to that remote repository is by this name. And then what exactly is going to be the remote repository is this URL. Right now I'll say git remote v. Right, I'll say git remote v. Now it will show a list, right? So right now it is linked to one remote repository. So the name of the remote repository is origin and it shows a URL. Right, now I am good to go. So I need to say git push origin where I'm going to push. I want to push to origin, right? I want to push, right? I want to push. I want to say origin and then in origin where I want to push. I want to push to master. So whatever changes that I made in this master, I want to push these changes to the master branch in the remote. I'll say git push origin master. Right. So it needs my authentication, right? So either you can do it via browser or in some cases it will ask you in your terminal itself, right? So I'll say password. I'll give my GitLab credentials. Right. So I gave my GitLab credentials and now I'm getting the message. It says uh, to HTTPS the URL of my remote branch and then it says a new branch created. So I go here and then I'll refresh here. So I should be able to see my local repository here, right? So this is my dashboard. In my dashboard, I've created a project. I've created a project called NTW2025 demo. This is a public project, and I'll go to this project. And by default, I have this master branch, and this is the change that I have, right? So now I can make change here as well. For instance, in my second.txt, uh, I'll go and say edit, right? I'll say edit. I'll say web IDE. I'm making a change in the remote. Right, I'll go to second.txt. This is an update in the right. So meaning changes are not exactly done in the remote itself. So changes done by some other developers now will be merged in the remote. So typically here I'm going to simulate how exactly we can pull changes from the remote. So now the remote is going to have some changes which is not there in the local. Right. So we saw push. We are going to see how we can get to pull. Right. So now this is an update in the remote master. Right. So I'll simply commit it. I make change and then I'll commit it. Right. Success. Your changes have been committed. Go to the project. Right. So now you can see the commits here. I'll go to code and then I'll go to see commits. So these are the commits. All these commits are done in the local. I can see one commit here that is made in the remote, right? That is made in the remote. I'll go to the local, git log. So I'll say git log. The last commit that I can see here is the manual merge feature one. Whereas here on top of manual merge feature one, remote is having a one change. Remote is having one change. Now this developer needs to pull the change to the local, right? So how this can be done? I simply need to say git pull from origin. So now instead of git push, I'm saying git pull origin master. Right. So now this will pull all the changes that are there in the master. Right. Right. And apart from that, here if you have multiple branches, one can, for instance, here typically developers will get to push changes to their individual branches. Here you can see a list of branches. So how do we get to do a merge, right? So here you can raise merge requests. Right now you can see here there are no merge requests. One important thing that developers will do is after pushing changes to their branches, they will create merge request. So I'll go to merge request. As a developer, you can create a new merge request. You can select your branch and then you can select the target branch. Right. So right now there are no branches there. And then you can raise the merge request. You can select the reviewer will get the notification. So once the merge request is being raised, the reviewer will get the notification in his mail, and I know through which he will review things, and then if the changes are valid, he will get to approve, and then he will approve that merge. Once the merges are approved, your branch will then get approved merged to the master, right? Right. So now how do you clone this repository, right? Uh, Meaning, how do you how do you get a copy of this repository in your local? For instance, I'll go here. I need to copy this repository, right? I want this repository in my local, right? So I'll go to code. I'll copy the URL. I'll copy the URL, right? I'll go to my workspace. So in this case, I'm going to clone a new project. It is not an existing project, but rather a new project. I'll go to my workspace in this case, right? This is my project. This is one of my project. This is my workspace. In this workspace, I'm having three projects. Now I want to clone one more project. This is a project that I've created in local. This is also now available in my remote as well. Now I have a remote project that I want to clone to my local. Right? I'll open a terminal here. I'll just say git version just to ensure I'm able to run git command in this command prompt. It's working now. I'll say git clone and followed by the project that I want to clone. Right. So this is a private project, but I've already authenticated, hence I'm able to clone the project. Now I should be able to see the project here, right? And then I can make changes here and I can make commits here. And I can, once commits are there, I can push to the remote repository and then do the steps. Right? So typically you can try with some of the open source projects. right? And apart from that, one other important thing that you can do is something called fork, right? So fork is how you can get your own copy of a public repository, right? There are a lot of interesting public repository that are available, right? So how do you own that, or how to get a copy of that repository in your account? For instance, this is my project, right? This of course is a private project. You won't be able to see it. For instance, I'll go here, right? Assume if I'm sharing this project with you, now this is a public project, right? Assume if you want access or you want a copy of this project in your account. This is in my account. In your account, what you can do, um, you can go to this project and then you have an option called fork. You click fork, and then you can select the the account to which you want to fork. Now that this project already in my project, hence it's not showing the appropriate option. So in your case, it will show a different option. It will ask you to select your account. You can select your account or group, and the moment you do that, you will get your own copy of this project in your account. And this is how you can get to fork. Right. Some of the interesting thing that you can do is you can find public projects in GitHub, interesting public projects in GitHub, and then you can get to fork that project in your account, and then you can start work on that. Right. Typically you can fork the public projects, you clone the public projects in your local, you make changes, and then you can work on that. Typically all these MVPs, right, minimal viable products, open source products, they are available as public repositories in GitHub, right, or rather GitLab. For instance, this VS Code that we were working, this editor itself, the source code, you'll be find it in GitHub, right? Right. So we saw how to install Git. We saw what configuration that it required, how we can set up a new Git repository, how we can track and stage changes, commit changes, view commit history. So by saying git log, we can view commit history, how to create and switch branches, merge branches. We also saw what are these online Git platforms. We know that there is something called GitHub, GitLab, and Bitbucket. We in fact work with GitLab and the features, some of these collaborative features, right? And what is the collaboration includes? You can get to review and comment on code. You can track the issues. You can get into discussions, and then you can have wiki pages. We can have project boards, just like I showed you that simple boards. You can have Kanban kind of boards here. You can manage your projects using group. See, primarily, Amir, you need to have the project as private project. So you should not have that project as public. So the primary thing is you need to have a private project, and then you need to provide an appropriate access control. Right, appropriate access control. Provided the appropriate access control, no one will be able to duplicate the project. For instance, if it is private, not everyone will be able to see the project. And once it is private, you can provide controlled access to the members. So you can typically, if you don't want others to edit the project, typically what I do is I'll typically give the reporter access, for instance. Fine, Amir. So it is about creating the project as private and then giving controlled access. Fine, Amir. That answers to your question. Right. So some of the other stuffs that you can try out, like I mentioned, you can explore on branching strategies. So this is key to manage the changes. Right. We did merge. You can also explore what is rebasing. Rebasing is like it is not about merge, like the name suggests. It will actually place all the commits next to the commits. Right. It won't typically merge. Right. And then you can see what is cherry picking. Git hook, it's something that is you know we can hook methods. We can hook methods to the Git activities, submodules and subtrees. Right, these are some of the things that you can explore once you are accustomed to the basics. Right, and these are the references. You can refer from Git SCM itself, or you can refer in Atlassian as well. Right. I think that's it from me for in this session. Thanks for joining in. I hope this session is useful for you in terms of getting introduced ourselves to the concept of SEM and Git. And if you have any questions, you can ask. Right, I think if there are no questions,
Okay.
um,
All right.
yeah,
Well, if you have any questions, you can use the chat box or you can unmute your mic. But if there are no questions, thank you so much for joining the session today. And you can check the WhatsApp group or community for any classes that you are interested to join. So we'll be announcing the classes every day. So again, thank you so much for your time, Sir Deepan, and for everyone. I hope you enjoy the rest of your weekends.
yeah. Thanks, Tony. Thanks, everyone. Thanks for joining in.
Oh, by the way, please don't forget to fill out the attendance form. Um, this will be your proof that you have attended this session, and I also included the second link where you could download your certificate. Okay, thanks everyone, and we hope to see you with our succeeding classes for the next week. Thank you, sir.
Yeah, thanks, Tony. Thanks, everyone.